How to fix input shape error in TensorFlow Dense layer for your neural network project. In the world of machine learning and deep learning, TensorFlow is a powerful library that is widely utilized for building neural networks. However, even seasoned developers can sometimes run into common issues, such as the dreaded input shape error in a TensorFlow Dense layer. This guide will guide you through understanding and resolving this error, ensuring smoother progress in your neural network project. Understanding the input shape error. When defining a dense layer in TensorFlow, you are required to specify the input shape, especially within the first layer of your neural network. This tells TensorFlow the shape of the input data it needs to expect. If this shape does not match the actual shape of your input data, TensorFlow will raise an input shape error. Common causes of input shape errors. Incorrect input shape definition. Ensuring the input shape passed to the first dense layer matches the training data shape is crucial. A mismatch could lead to input shape errors. Dimension misalignment. Neural networks, especially those involving multiple layers, need consistent data dimensions to function correctly. Misaligned dimensions between layers can cause errors. Flattening before dense layer. Often, an input passed through convolutional layers needs to be flattened before feeding it to dense layers. Neglecting this step can result in shape mismatches. How to fix the input shape error. Step 1. Verify the input shape. Verify that the input shape provided to your dense layer matches the actual shape of the input data. The dense layer expects a 1D input vector. Here's how you can specify the correct input shape. In this example, input_dim should correspond to the number of features in your input data. Step 2. Reshape or flatten your data. If your input data comes from previous layers such as convolutional layers, make sure to flatten it before passing it to a dense layer. By adding a flattened layer, you ensure the multidimensional output of convolutional layers converts into a 1D tensor, suitably formatted for a dense layer. Step 3. Debug using model summary. Use the model.summary method to provide details of the network and identify where the dimension mismatch occurs. This gives you an overview of the layers, their output shapes, and the parameters, making it easier to pinpoint any mismatches. Tips for avoiding input shape errors. Consistent data preprocessing. Ensure that all input data is preprocessed consistently, especially during resizing or reshaping. Explicit dimension handling. Always be explicit about the data dimensions at every layer to avoid surprises. Regular validation. Frequently validate input shapes throughout your model building process. By following these steps and tips, you should be able to mitigate and resolve input shape errors in TensorFlow Dense layers, thus enabling efficient model development for your neural network project. Happy coding!